This video is going to show the deriving of equivalent resistance for a parallel circuit, like the one you see above. The first thing we'll need to show is how current is related in a parallel circuit. And so I will write that down here. So there's current in a parallel circuit, and the current through each track added up equals the total current. Now what we need to do from this starting point is to substitute voltage and resistance in for all of these different currents. So we're going to do that using Ohm's law. If we solve Ohm's law for current by dividing by R, we will get I equals V over R, and we can substitute that in for each of these. So I'll do the first one quickly. Voltage total over resistance total is the same as current. We can do that for all three of these. I see that voltage was and resistance was substituted in for each of these. And now what we need to do is a little bit tricky. We need to divide by voltage, because we know that in parallel, voltage total in parallel is equal to the voltage to the first track, second track, and third track. These are all going to be the same number. So we can actually divide both sides by voltage total, like you see there. Okay, so obviously they'll cancel here, leaving us with 1 over resistance total. And then we need to distribute this to all three. So I'm going to do it and show the first one very quickly, and then I'll jump ahead with the whole expression written out. So if I distribute that to the first one, I'll have voltage 1 over resistance 1 times our multiplier 1 over, I'm going to write voltage 1 because we know that voltage total and voltage 1 are the same thing. I can substitute voltage 1 in for here. Okay? And then I have to do that for these other two tracks as well. Okay, there you'll see all of that written out. We've got first track, second track, third track, and we're going to cancel the voltages on each of those, leaving us with 1 over resistance total equals 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance to the third track. And you will see this equation quite a lot. If you looked up equivalent resistance in parallel circuits, you'll probably find this one. But maybe that's not so good for us when we're actually trying to calculate resistance, equivalent resistance. That's because it's on the bottom of the denominator here. Maybe an easier way to actually calculate would be have resistance total on top of the fraction. So I'll kind of demonstrate how that's done right now. We actually need to do that by multiplying both sides by the resistance total. That's of course to get resistance total in the numerator. Okay, so it cancels here. Now we have resistance total in the numerator. I'm going to write that out just below. Alright. And now, in order to get resistance total alone, I need to divide by this whole expression to get resistance total alone. So go ahead and do that. 1 over R1 plus 1 over R2. Obviously this cancels, but what I do to one side I have to do to the other. So I'll put it over there. And now to rewrite the whole thing, resistance total is equal to 1 over this entire expression. 1 over R1 plus 1 over R2 plus 1 over R3. And that is a good expression now for us to calculate equivalent resistance in a parallel circuit.